All right, hey everyone. Let's dive deep into cloud security today, especially if you're prepping for that CCSP exam. We're going to hit those essentials you got to know about building secure solutions, up in the cloud.
Yeah, think of us as your CCSP exam toolkit, right?
Okay.
We're going to highlight the must-knows, really dig into why they matter.
Exactly. It's not about covering everything, right? It's about giving you a solid foundation.
To build on as you study, exactly.
So first things first, building secure solutions in the cloud. It might seem kind of new, but it really pulls a lot from what we already know, right? About securing on-premises systems.
Absolutely. Those core principles, they don't just disappear.
Yeah, they stick around.
Think of it as you're taking those security practices you're used to and just adapting them to the cloud.
Right, like translating them to this new environment.
Yeah, exactly. And one of the biggest ones that carries over, super fundamental, it's defense in depth.
Defense in depth, yeah, that's huge EE, both on-prem and in the cloud.
It's not about having just one strong security measure, right?
No, it's got to be layers.
Layers of security. Overlapping, they reinforce each other.
Right, so if one layer fails, you got another one to catch it.
Exactly. Instead of just a firewall, you'd also have intrusion detection systems,
Oh yeah, strong authentication too.
Data encryption.
Got to have that. It's like building a fortress, right?
Exactly, with those moats, the walls, guards, the whole 9 yards.
Multiple layers of protection. And this layered approach, this defense in depth, it's a key concept for the CCSP exam, right? Specifically in the cloud security architecture domain. You want to be comfy with that.
Oh yeah, for sure, how it applies in the cloud.
Absolutely. So let's move on to a specific security measure plays a crucial role in that layered defense. The web application firewall.
Or as the cool kids call it, WAF.
WAFs, all right? Imagine this, okay? You've got your web application up in the cloud, right? Serving up data, doing its thing. A WAF is like a shield, protecting it from all those web-based attacks.
It's like that gatekeeper.
Oh, I like that.
It analyzes those incoming HTTP requests.
Scrutinizes them.
Filters out the malicious traffic, stops it from reaching your application. It's your first line of defense against, those common threats.
Like what kind of things are we talking?
Like SQL injection, cross-site scripting, all those vulnerabilities hackers try to exploit.
So we're talking stopping those sneaky attempts to mess with your web app, basically.
Yeah, keep those bad guys at bay.
And there are a few different ways to deploy a WAF, right?
You got it. You have hardware WAFs. Those are physical appliances installed on your network.
Right.
Then you got software WAFs run on your web servers.
Yeah.
But more and more organizations are going for cloud-based WAFs.
Oh, yeah. Cloud-based WAFs.
They're provided as a service by cloud providers.
Cloud-based WAFs. So those sound particularly interesting when we're talking cloud security.
Well, for one thing, they're very scalable, right?
Right. Makes sense.
Cloud providers have those massive infrastructure, can handle huge amounts of traffic.
So they can take the hit.
Yeah, and that's essential for those DDoS attacks.
Distributed denial of service.
Exactly. It's a major concern in the cloud.
So if you get hit with a traffic surge meant to overwhelm your application,
the cloud-based WAF can just absorb it.
And keep everything running smoothly.
That's right. Big win for resilience there.
Big time. And cloud-based WAFs, they're easier to manage too, right?
Usually, yeah. Provider handles all those updates, maintenance, all that stuff.
So your team can focus on, the other parts of security.
That's the idea. Freeze them up.
Now, before we move on, got to ask about a specific type of WAF, the XML firewall. What's the deal with those?
Oh, XML firewalls. Those are specialized WAFs designed to protect APIs and web services that use XML for data exchange. They inspect XML traffic, looking for anything malicious, attempts to exploit vulnerabilities specific to XML-based applications.
Gotcha. So if you're building applications in the cloud and they expose APIs or use XML.
You got to be thinking about those XML firewall capabilities.
To secure those interactions.
For sure. And a lot of times you'll find that functionality built into broader WFs or API gateway solutions, so you get comprehensive protection.
Right, for all those web apps and services. Okay, so we've talked about securing our applications, but what about the data itself? It's not just about keeping it safe from, the wrong hands, but also making sure it's properly anonymized.
That's a critical point, especially with sensitive data in the cloud. Anonymization, it goes beyond just removing obvious identifiers.
Yeah, like names and addresses, that's not enough.
Exactly. You could remove a name from a data set, but if you still have things like age, location, medical history...
You still identify someone.
It might be possible, yeah. That's not true. Anonymization.
Right.
And that's where techniques like Data masking, generalization, pseudonymization come in.
Those are big words.
They are. But basically, they alter or obscure data, making it harder to link it back to a person.
While still keeping it useful.
Exactly. Still useful for analysis, other purposes.
So we're talking about de-identifying the data, right? In a way that protects privacy, but lets us still use it.
You got it. It's a delicate balance.
It is. It is. Yeah. And when you're studying for the CCSP exam, you'll want to know those different anonymization techniques.
And what they mean, yeah.
The exam, it often tests you on protecting sensitive data while still complying with privacy regulations.
Oh, for sure.
Speaking of regulations, IP comes to mind, right? The de-identification standard.
Absolutely. That's a big one, especially with healthcare data moving to the cloud.
It lays out those specific guidelines for protecting health information, which is, really relevant in the cloud these days.
Big time. IPA outlines two main approaches to de-identification.
Oh, okay, lay 'em on me.
One is expert statistical analysis
Right.
to see if the risk of re-identification is low enough.
So you're crunching the numbers.
Yeah. And the other one uses a safe harbor method where you remove specific identifiers.
There's names, addresses, social security number, that kind of stuff.
Right. So with the safe harbor approach, you're taking away those most obvious data points.
The ones that could be used to identify someone.
But it's important to remember, even after removing those identifiers, the data might still have privacy risks.
Oh, for sure. Context is everything.
Exactly. You got to think about what other data is there, how it could be combined, and the potential risks of re-identification.
This is all fascinating stuff. It really shows how data security in the cloud goes beyond just those technical measures, right?
Yeah.
It's about privacy, ethics, and complying with those regulations.
You got it. It all ties together.
It really does.
You're absolutely right. It really does. And speaking of those technical measures, let's talk about encryption.
Okay. Yeah, encryption. That's got to be a big one.
It's like one of the most fundamental things we've got for protecting data, right?
Yeah, keeping it confidential.
In the cloud, especially.
Encryption. Makes sense. It's like putting your data in a locked vault.
Yeah.
Only authorized users can get in.
Exactly. But the cloud, it adds some complexity to it.
Oh, for sure. It's not just data sitting on a server in your basement anymore.
Exactly. When we talk data in the cloud, we got to think about both data at rest and data in transit.
Data at rest, data in transit.
Data at rest, that's data that's just stored, right?
Sitting on those hard drives.
On those hard drives, SSDs, in the cloud providers' data centers.
Right.
Data in transit, that's data on the move.
Traveling.
Over the internet, within a cloud provider's network, all that.
So we got to protect it both when it's chilling and when it's on the go.
That's right. And that's where encryption comes in.
Makes sense.
For data at rest, we encrypt the storage volumes, the databases, wherever it's stored.
Lock it down.
Cloud providers offer all sorts of encryption services to make that easy.
Oh, nice.
For data in transit, we use protocols like TLS that encrypt the data as it's moving across the network.
So whether it's hanging out in a storage bucket or zipping across the internet, encryption's got our back.
Keeping it all confidential.
That's good to know. But encryption brings its own challenges, right? Like managing all those encryption keys?
Oh, yeah, for sure. Key management, that's critical. If those keys get out, encryption's useless.
Game over.
But luckily, cloud providers, they got these robust key management services.
Oh, my goodness.
You can generate keys, store them, rotate them, all securely.
So we don't have to be like master locksmiths ourselves.
Nope. Let the cloud provider handle that.
You use their expertise.
Exactly. And these services, they provide a really high level of security and control. You can set who can access the keys, manage them.
You got granular control.
You can even use hardware security modules, HSMs.
HSMs? What are those?
Those are like specialized hardware devices.
Okay.
Built for secure key management.
Gotcha. So they're like super secure.
Yeah, tamper-resistant storage for your keys.
Like Fort Knox for our encryption keys.
Exactly.
Yeah.
Makes it really, really hard for anyone to compromise them.
That's reassuring. All right, let's shift gears a bit. Identity and access management. IAM? Yeah. That's going to be a big deal in the cloud, right? With users accessing stuff from everywhere.
Huge deal. IAM is fundamental to cloud security. It's about controlling who gets to do what.
Making sure only the right people can access the right stuff.
Exactly. Only authorized users and applications can access sensitive data, perform certain actions.
It's not just keeping the bad guys out, it's making sure even the good guys don't accidentally do something wrong.
That's right. IAM involves things like authentication, proving you are who you say you are.
Right.
And authorization, figuring out what you're allowed to do.
Okay, so Two different check.
And we use tools like multi-factor authentication, MFA, role-based access control, RBAC, and identity federation to manage all that.
Multi-factor authentication, MFA, I hear about that all the time. What makes it so good?
MFA, it adds another layer of security.
Another layer.
By making users prove their identity in multiple ways.
Not just a username and password.
Right. They might need a code from their phone or a biometric scan, something like that.
Makes it way harder to hack in, even if someone steals your password.
Exactly, like having 2 locks on the door instead of 1.
Makes sense. And role-based access control, RBAC, how's that work?
RDAC, that's managing permissions based on someone's role or their job.
Okay.
Instead of giving permissions to each person, you set roles, and those roles have specific permissions.
Right.
Then you assign users to those roles.
So like a developer role might be able to deploy code, but not access production databases.
Exact. You're not giving everyone keys to the kingdom, just what they need for their job.
Smart. Minimizes the risk of, accidental stuff happening.
Or malicious stuff, yeah. If a developer's account gets hacked, the attacker can't just access everything.
It's like different levels of security clearance, right?
You got it.
Okay, and you mentioned identity federation. What's that all about?
That's a way to let users from one organization access resources in another organization without having to create new accounts and passwords everywhere.
Makes things easier.
It's used a lot when organizations collaborate.
So if your company's working with a partner, you could use identity federation so your employees can access their stuff.
Using their own company credentials.
Slick. Simplifies things, makes it more secure.
Right. Less passwords to manage.
Big plus. Okay, so we talked about encryption, key management, IAM, all super important for cloud security. But the cloud, it changes all the time, right?
Oh, yeah. Constantly evolving.
New threats popping up. How do we stay ahead of the game?
Good question. It comes down to logging and monitoring. Think of it like a security camera system, but for your cloud environment.
Logging and monitoring, yeah. Like a security camera system for your cloud.
Exactly. We got to keep an eye on what's happening, right? Look for anything suspicious.
Anything that screams security breach.
Right. Logging means collecting data about events, activities in your cloud systems.
So like a record of everything.
Again, monitoring means analyzing those logs.
Looking for those patterns, red flags, anything out of the ordinary.
Exactly. That's where SIEM tools come in.
Security information and event management. SIEM. Yeah. Those are powerful tools.
They gather logs from everywhere, correlate events.
Make it easier to see the big picture.
Exactly. Give you dashboards, alerts, help security teams respond faster.
I've seen those in my CCSP studies. They seem pretty awesome. But there's so much data, right? How do you know what to focus on?
That's where threat intelligence is key.
Threat intelligence.
Knowing about the latest threats, vulnerabilities, attack techniques.
So you can spot them.
Exactly. You configure your monitoring systems to look for specific things.
So you're not just drowning in data.
Right. And you can prioritize your response.
Focus on the biggest threats first.
Exactly. It's about being proactive, not reactive.
Always stay ahead of the game.
That's the goal. And that brings us to incident response.
Incident response. Okay.
Even with the best security, breaches happen, right?
Unfortunately, yeah.
You got to be ready to respond quickly.
Minimize the damage.
Exactly. A good incident response plan lays it all out.
Roles, responsibilities, who does what.
Communication, escalation procedures.
So everyone knows what to do.
Right. And it includes steps for containing the breach, getting rid of the threat.
Recovering systems, all that.
And then doing a post-mortem.
Like figure out what happened.
Learn from it, improve security for the future.
So it's like a fire drill, but for security.
Exactly. You practice so you're ready when it happens.
Makes sense. And documentation is important, right?
Crucial. Document everything, track progress, report to the right people.
So you have a record of what went down.
Right. Now, we've talked a lot about shared responsibility.
Shared responsibility in the cloud, yeah. That's a big one for the CCST exam.
It means security isn't just the cloud provider's problem or the customer's problem.
It's both.
It's a shared responsibility model.
Okay, so how does that work?
Cloud providers secure the infrastructure, the data centers, the networks.
The foundation.
Exactly. Customers secure their own apps, data, user access.
So it's like renting an apartment.
That's a good analogy.
Landlord secures the building, you secure your apartment.
Exactly. Understanding that shared responsibility is key to good cloud security.
You got to know who does what.
Right, so you can put the right security controls in place.
It's a partnership, right?
Absolutely. Cloud provider and customer working together.
Wow, this has been an amazing deep dive.
We covered a lot of ground today.
Defense in depth, WAFs, encryption, IAM, logging, monitoring, incident response, shared responsibility.
It's a lot, but it's all connected.
I feel like I have a much better grasp on cloud security now.
Glad to hear it. Remember, cloud security never stops.
It's a journey, not a destination.
The threats are always changing, so stay informed, stay vigilant.
Adapt and overcome.
That's it. Thanks for joining us today, everyone.
Best of luck with those CCSP exams.
You got this.
And remember, a secure cloud is a team effort.
Working together.
Keep learning, keep pushing the boundaries of cloud security. And join us next time for another deep dive.